Welcome back to Engineering Acoustics. Hi, this is Professor Ryan Harne. We're often encouraged to protect our hearing. In this video, we'll learn all about hearing protection products and what makes them effective.
So let's get started. There are many hearing protection products for personal, industrial, defense, and commercial use. They include things like earplugs on strings, earplugs in individual packs, headsets, active control headsets, and more. Not all solutions are equally creative, especially given the fact that users might misuse or misfit these products. So, this video asks, what hearing protection products are effective, what makes them effective, and what noise environments warrant hearing protection? We'll answer these questions in reverse order. We know that hearing damage occurs for sounds in excess of 85 dBA, and we know that there is a relationship between the time of exposure, the amplitude of the sound level exposures, and the hearing sensitivity loss. Even if these temporary threshold shifts go away, they will result in permanent hearing loss at a faster rate than without this exposure. So if we consider common activities that we might be involved with day to day, we see that vacuuming leads to OASPLs around 70 to 80 dBA. Using a lawnmower or wood shop or metal shop equipment would lead to OASPLs around 90 dBA. The nearness of sirens in our job, or the use of masonry tools like hammer drills, leads to OASPLs around 100 dBA. Going to concerts could expose us to sound levels from 100 to 140 dBA. And using firearms will expose our ears to sound pressure levels of over 130 dBA. Whenever the sound levels approach or exceed 85 dBA, we need to apply hearing protection, even for short-term activities, to lower the sound levels that actually get to our ears and minimize the risk for permanent hearing loss. So what makes hearing protective devices effective? Well, hearing protection products block noise from entering the middle and inner ear. A rule of thumb is that if air is able to pass into the ear, then so will noise. So hearing protective solutions need to entirely seal air from passing into the ear canal. The most effective use of hearing protection is informed use, where people know how to correctly apply and fit the earplugs or earmuffs that they're using for comfort. So for instance, in this photograph, this person is wearing earmuffs on the side, which will have very little effect since they're intended to be worn up and down over the ear. Interestingly, even for people in the workplace who report wearing hearing protection, data shows there's negligible preservation of hearing threshold, and this clearly suggests that these users are incorrectly wearing hearing protectors. How do we quantify the success of hearing protection? Well, the EPA in 1979 released a report on product noise labeling requirements that introduced the noise reduction rating, NRR. You'll find all hearing protection products are published with a measured NRR that estimates the adequacy of the hearing protector attenuation. It's measured by considering how the OASPL that transmits through the hearing protector is reduced using tests involving 1/3 octave band, 100 decibel band limited noise. And NRR is one number that suggests the overall sound level reduction that could be achieved if the hearing protection device is fit correctly. Let's first consider earplugs. The appropriate fit for earplugs is to squeeze and roll the foam earplug. Place it into your ear while it's still rolled up. Place it in a way that you can just hold on to it when it's in your ear canal, but don't press deeply enough that it's touching your ear canal or you can no longer grab it. And then release hold of the earplug. It will expand and seal the ear canal, stopping air from passing to the eardrum. To remove the earplug, gently pull on it. Do not harshly pull on it because this can injure your ear canal or it can injure your eardrum. But once correctly fit, they perfectly seal the ear canal that leads to excellent attenuation of sound. But earplugs are not sufficient when sounds exceed 105 dBA. We need greater protection under that case. and this is the use of earmuffs. They fit over the head, they fully enclose the entire ear, and they include a dense polymer shell with an absorptive interior material that lessens sound reverberation in that chamber around your ear. Earmuffs are more obtrusive than earplugs, but they're less often ill-fit by users. And combining earplugs and earmuffs is one way of attenuating sounds in excess of 120 dBA. The way we combined noise reduction ratings in RRs is to add around 5 to 10 dB if we add one with the other. And one common misconception when people are out working with loud equipment is that they listen to headphones to introduce music that blurs out the noise. But listening to headphones is not a substitution to protecting our ears. It is more damaging than having just our ears exposed to the noise itself. To summarize what we've learned, earplugs and earmuffs lead to similar noise reduction ratings in our Rs around 25 to 35, but the selection of which hearing protector we use depends on the user and the environment. And for those who are exposed to loud noise, the lack of hearing protection is a guarantee to experience accelerated noise-induced hearing loss, NIHL. So the correct fit and the elimination of that air path is essential for the hearing protection solution to do its job and to preserve your hearing.
That's it for this video. Now we know all about acoustic waves, sound inside and out, and how we manage and control noise. In the upcoming videos, we'll focus more closely on the mechanisms of human hearing and how these detailed behaviors can be leveraged for a wide variety of interesting applications.